20 or 50 locations in one shot. You need to do it sequentially. You need to do it by incrementing the address continuously.
Professor,
Yes.
are you just assigning the word over this right here by by this right here, the 0 comma x? Are you just assigning that to over or something, or what's going on here? I don't know what's that line right there.
No, over here is for this one, branch of not equal to over.
Branch not equal to over, and then you repeat. So this is kind of like a loop or something.
This is a loop.
Oh, okay.
This is just taking two lines. That's the difference.
Okay.
The following program clears 2 RAM locations at one time. Yeah. You need to be able to master those little things, you know, in preparation for the final. And there's a lot of applications here for the there is an instruction called move instruction, by the way. Look at that. There is a move instruction. In very early versions of assembly language programming, I didn't see the instruction move before, but in this 6800, I mean, languages change, by the way. But the very basic assembly language programming, they didn't have the move. It's like they didn't have the divide instruction. The multiply and divide. We used to do multiply and divide the hardware, but now they are part of the language. By the way, there is a special meaning for 55 and AA. Here, this example is very interesting, and it's probably going to help you in lab 3. I already sent you lab 3 to the web. I think it was yesterday, and I don't know how are you doing in the summer. Maybe I will need to chat with Samson about that too, because summer is too short, and I like to make sure that your learning curve is not causing any issues when it comes to speed handling those labs. But we have a total of 5 or 6 labs. I used to give a total of 6 labs. Sometimes I can make them 5 labs, and possibly a project. We probably by Wednesday, or at most next Monday, we're going to talk about projects. So let us see. I will consult with Samson first to see how you guys are doing in the lab before we would decide about the complexity of the project or the intensity of the project. But this is part of lab 3. This is going to be part of lab 3. I consider that if you have done labs 1 and 2 so far, that's a good accomplishment. That's a good achievement. But the real assembly language programming is going to start in lab 3 eventually, because you're not using a simulator, and also you are not unaware of assembly language program. Remember, in lab number 1, you were totally unaware of assembly language programming, and in lab 2, you were totally ignoring the actual hardware. You were not doing hardware. Everything was a simulation. So now the actual lab actually starts with lab 3. These are the real, this is the real life, you know. Lab 3 and on, this is real life, you know. You know what you're doing, you know what kind of assembly language programming you're writing, and at the same time, you are utilizing the full capabilities of the trainer. That's lab 3. Jump to subroutine delay. Yeah, who placed this mark here? Jump to subroutine delay. Who said?
I did. I don't know what that means.
Who is talking?
Prince. It's me. Prince Ramos.
I like your name.
Thank you.
This is very important. That's a very important. Okay, let me say this. Port B, as you know, is connected to the light emitting display, light emitting diodes. And when you say move 55 to port B, what is it? That means from the right to the left, it's going to read 10, 10, 10, 10. That's going to be on port B. So wherever you see a 1, the port B is going to be lit. Wherever you see a 0, it's going to be off. So you're going to see on, off, on, off, on, off, on, off. Okay. We would like to do the opposite here. We're going to move the 50. We want to make the 55. We want to make it AA2. So we want to do the opposite. So instead of doing 55, we're going to do AA. You know what AA is? AA is 0, 1, 0, 1, 0, 1, 0, 1, from right to left. I'm talking from right to left.
I think it's 1, 0, 1, 0.
I'm saying from right to left.
Right.
Yeah. Yeah, it's like writing Arabic.
Oh, okay.
You know which languages start from right to left in this world?
Japanese? I don't know.
I don't know about Japanese, but I know about Arabic. There is also the Persians. There is also the Hebrew, I guess. All these guys, they are all in the Middle East, by the way, right from the right to the left. So when I say 0, 1, 0, 1, 0, 1, 0, 1 from right to left, that's equivalent to 10, 10, 10, 10 if you read it from.
So that's how, okay, I got it.
Yeah.
That's how you're reading it.
So that's another. So that's a reference. All right. So your question is very important. Is extremely important.
Okay.
Why is there a jump to subroutine delay? Why do we need a delay here? Because you cannot lit the light emitting display for a microsecond, for example. It doesn't make sense to make it on for a microsecond and then go to the next instruction and do something else. You see what I mean? You cannot switch from 0 to 1 in 1 microsecond. The human eye has limitations.
Okay.
The human eye has limitations. You need to have it there for a while, like this. And for the diode also to persist, there is something called a phenomena called the persistency of the diode. That means the diode has to be on for a minimum period of time in order for you to consider it to be on. How do you find that time? Look at the data sheet of the light emitting diode. see something like the persistence time, or how long should it be on in order for us to perceive it as on. You see what I mean? So that's why there is a delay, because usually we put the delay here several milliseconds.
Okay.
Let us say, that could be 50 milliseconds maybe, or 100 milliseconds. So if
So
you,
so what happens if you don't put that? Like it'll give an error?
it will be an erroneous answer. You will not be able to distinguish between the bits that are lit versus the bits that are off,
Okay.
because you're probably gonna see it all neither lit 100%, neither nor off 100%. You're gonna see some hazy picture which doesn't make sense.
Right.
So the best way to do that is to execute that instruction, then go to delay. The delay here guarantees that this port stays in this situation for a while. You need to keep it. You need to keep the bits that are on as on for a while.